the measurement obtained through the stage sensors, the estimation made through the stage sensor, with the actual volume deposited in this basin that was surveyed using terrestrial laser scan techniques, photogrammetric techniques, and so on. The results show that the formula that I showed you before overestimates the volume of about 50%. The volume deposited in the occasion of this event was estimated through the terrestrial laser scan in about 8,000 cubic meters, while the formula that I showed you before estimated a volume of about 15,000 cubic meters. If you consider also that about 1,500 cubic meters just flowed down through the slit, you can obtain the rough estimation that I gave you before. So this specific instrumented basin is particularly prone for making estimations of the possibility to measure the volume through the use of stage sensors. So researches are currently going on, and we expect to obtain interesting results in the few coming years. Okay. Now, another tool that is very important in monitoring debris flows, given their field characteristics that impede the use of contact sensors, such commonly used in hydraulics. I mean, current meters or weighers. Of course, it's not possible to use these tools in monitoring debris flows. So video cameras can be particularly useful, and I think that the two videos that I showed you are a good demonstration of what I'm talking about. Video cameras have been also employed to measure surface velocity through the video image processing. And so stage sensors and video cameras are broadly used in the monitoring of these phenomena. Then we have the broad class of ground vibration sensors. As I mentioned before, there are seismometers, geophones, microphones, hydrophones that can be used, and processing the raw data that comes from these type of sensor, one can obtain the graph that I showed you, that I'm showing here, and again, it's very easy to recognize the passage of the main front and also the passage of secondary waves if they are present. So also these also the ground vibration sensor can therefore be used to make measurements such as mean front velocity, the velocity of secondary waves, and also to detect the waveform of the phenomenon that is taking place in the torrent. Now, let's skip and talk a little bit about warning systems, even though it's not possible, as I told you before, to keep these two fields completely separated with each other. Warning systems can be classified in two main big categories: advanced warning systems that are based mainly on the use of rainfall measurements to predict the possibility to have a debris flow and so spread a warning, or the so-called event warning systems. This classification comes from Hanger, 1987, and the event warning, as the word itself says, are those sensors that can those systems that can detect the occurrence of a debris flow during the event itself. We can share again these two systems, separating the contact sensors from the remote sensors. So let's see an example of contact sensors. Of course, the wire sensor that I showed you before in the list produced by Itakura. this is one of the most common sensors employed in the monitoring and warning of debris flows. Of course, it needs maintenance after the event. Another type of contact sensor is the pendulum. You can see an example here. We are in the Maurienne Valley in France, in the Saint Bernard catchment, and you can see here 3 different pendulums placed in the torrent, and they just gave a warning through teletransmitting the datum down to the village downstream. Here is another example of use of pendulums in the Ravoir torrent, also in France. And then there is the broad class of remote sensors. One of the first is, of course, the stage sensor. Here is an ultrasonic sensor used to monitor the passage of the flow. And of course, when you use remote sensors, you need to introduce the concept of an algorithm to detect the passage of the debris flow for spreading a warning. And a possible algorithm consists simply in measuring the difference between the stage in few seconds, and if this difference overcomes a certain threshold, let's say 20 centimeters, the warning can be spread. Of course, it's better to have more than one of these sensors along the torrent to avoid false alarms caused by the passage of animals or also human beings or something of the sort. In recent research's activity, however, the attention has been, this is just during the few last years, has been moved on the use of ground vibration sensors. The reason is quite simple, because video cameras, stage sensors, pendulums, and all of this type of sensor require to be hanged above the torrent. And this can cause several problems, several difficulties. One of these is when the torrent, and as it often occurs, just deviates its path. In that case, the sensor may be no more able to detect the passage of the debris flow simply because it's not more there. Another difficulty is given by the destruction of the sustaining structure. Because of the destructive power of these phenomena, the sustaining structures can be destroyed, and so you lose the sensor and also the possibility to spread a warning. Therefore, the attention has been moved on the use of ground vibration sensors, because they have several advantages. First of all, they are passive sensors. They do not require power supply. So in this case, moving and having to apply and install these systems in high mountain environment where the power supply often is not available, it's a passive sensor is much more prone to be used. Then they are not particularly affected by the deviation of the torrent bed, because they are placed, of course, outside of the path of the debris flow, and if the debris flow move his path, the sensor is still capable of measuring the occurrence of the flow. There is no need to be suspended above the torrent, and the detection of the arrival of the debris flow can occur at a distance. And for this reason, the passage of the debris flow can be detected several seconds before its arrival at the section where the sensor is installed. Moreover, this type of sensor can detect different and obtain different information regarding the debris flow, such as the intensity of the ground vibration velocity and the frequency of the signal that can be used for warning purposes, as I will show you in a few minutes. In this picture, you can see an hydrograph obtained through a stage sensor compared to the graph obtained with a ground vibration sensor. And as you can see from this line, the ground vibration detector is capable of detecting the arrival of debris flow several seconds before its passage close to where the sensor is placed. If you use a stage sensor, like in this case, you only detect the passage of the flow when the flow is under the sensor. So this is a big advantage